Now we're going to look at how to perform operations on some of the complex numbers when they're in that trig or polar form. Specifically, we'll be looking at multiplication and division. So here we're working with two different complex numbers. So you can see that we have z sub 1 to represent the first complex number and z sub 2 to represent the second complex number. Basically, they're just saying you're going to have an r cosine theta plus I sine of theta, and then a second r cosine theta I sine of theta. So for the two different complex numbers you have, and these are in the polar or trig form, the operations are actually very straightforward, because if you are multiplying the two complex numbers, then you just need to multiply the r values out front. That's what this is saying. So r1 times r2. And then for whatever your two theta values are, the two angles that you've been given, you just need to add those angles together. So it'll be cosine of the sum of the angles and I times sine of the sum of those angles. So if they are fractions, that means you will need to get a common denominator and combine the terms and do any of your like cross canceling or anything you can and simplify the fraction from the r1, r2 if those values are fractions. So this will work whether it's in the degree mode or radian. Also, I'll mention that many of the questions may have you change your answer once you've performed the operation. They often ask for the answer in standard form, which means you do have to use the conversion process shown in the last video, where you take that trig/polar form and convert it to standard form, a plus bi instead. So number 2 here is showing the other operation of division. So again, we have two complex numbers being shown here. So they'll say z1 divided by z2, or they'll just show z1 over z2. And very similar to what we did for multiplication, that means you're going to divide the r values, those numbers that are out front. So the number from the numerator and the number from the denominator stays exactly where you expect, on top and on bottom respectively. And then the operation on the angles. So whatever your two theta values are for the two complex numbers, this time you're going to subtract them. And again, that means if it's in fraction form, you do need to get a common denominator first. So radians are usually a fraction. Get a common denominator to combine them into one value. If it's in degree mode, then you can just go straight ahead and subtract the numbers. So I've also added a comment here to specify that I showed the operations with the complex numbers being in the trig/polar form. Now, if the complex numbers were given in standard form, that also means that you will have to do the converting so that you can get them into the correct form before you perform these operations. These operations are shown specifically for the trig-polar form, so if they're not in that form, then use the instruction in the last video to convert them first. So here's our first example. We've been given two different complex numbers, and the angles are in degree mode, so I won't have to worry about common denominators with fractions or anything. And the operation we've been asked to do is multiplication. Now this one specifies that they want the answer in trig form, so we're not going to have to take the answer we get and convert it. We'll just be able to perform the operation and stop there. So the important thing to remember is that if you're multiplying, that means we need to multiply the two r numbers together, and then we need to take those theta values and add them together. So here's the setup. I've got the 2r value, square root of 2 times 0.5, and you could think of this as 1/2, depending on if they seem to want the answer in a fraction form, or if they specify that they want a decimal run into a certain number of places, you may want one over the other. But those are the 2r values being multiplied together. And then our angles, we have 118 degrees and negative 19 degrees. Now, usually I showed you on the last slide that we should be adding the angles, but since this is a negative number, it ends up looking like a subtraction problem. But technically, I was adding these two angles. So 118 minus 19, and it's the same thing for both, the cosine and the sine part. You should be getting the same numbers for both of those trig functions. So next, we're just going to simplify this, clean it up a bit. So I've chosen to think of the value 0.5 as 1/2, and then I did 1/2 times square root of 2 over 1, multiply straight across, so the numerator times numerator and denominator times denominator. I usually prefer the fraction form when I have the choice. And then for the theta values, I was just combining 118 minus 19 is 99. Now, you could have also done this computation in your calculator to put it into a decimal form. So if you did that, your answer would be something like 0.7071, and then the decimal just goes on and on and on. But they didn't specify in the directions whether they wanted an exact answer or a decimal answer. So I chose this one. And again, many problems may also ask you not to write your answer in trig form, but to write it in standard form, which means you would then need to figure out what a and b are. We know that r is square root of 2 over 2, and we know that theta is 99 degrees, since that's the r cosine theta plus I sine theta. So we know what those two variables are, and then we would use those values to solve for a and b, using a equals r cosine and b equals r sine. But according to the directions on this one, we're able to stop right here. So here's an example where I see a complex number. I have an r cosine theta plus I sine of theta, so that's the trig form of a complex number, and they've shown it as a fraction being divided by another complex number. So they didn't say like find z1 divided by z2, they didn't write it out in that way, but it means the same thing. So fractions are just another way of saying to divide something. So now we're going to use the operations for division, which means that we need to divide the r values. The one on top stays on top, the one on the bottom goes on the bottom, so this number divided by this number. And then this time we're going to be subtracting our angles. So the angle on top minus the angle on the bottom. So here's the setup following the instructions from the formula. I have the 12 divided by 4 from dividing my two r values, and I'll simplify that in a moment. And then my angle on top was pi over 3, and we're subtracting the angle on the bottom, pi over 6. Your angles should match. It should be the same exact thing for the cosines and the sines. So pi over 3 minus pi over 6. Now this one's in the radian mode, so when you are simplifying this, don't forget to get a common denominator for combining those two numbers. So in red up here, I went ahead and showed what pi over 3 would be equal to if we got a common denominator. So if you multiply both the top and the bottom by 2, that would give you 2 pi over 6 instead. That way the two fractions would have a common denominator. So 2 pi over 6 minus pi over 6 is pi over 6. And it's the same value for the cosines and the sines. So I didn't need to recompute that over here. I just used the same value twice. I also simplified the 12 over 4 part here. So 12 divided by 4 is 3. And so this is our trig form, or our polar form, if they phrase it that way, for the division of those two complex numbers. Now, again, many questions may ask you to do the extra step of converting it back to standard form. So again, this shows that my r value is 3 and my theta value is pi over 6. So if I have to convert it back, as shown in the last video, you would do a equals 3 times cosine of pi over 6, and b equals 3 times sine of pi over 6, and then you would have those numbers, a plus b times I. So that's it for the notes on this section. That's how to multiply and divide complex numbers.